Welcome back to 13 Cubed. In this episode, we're going to take a look at a powerful PowerShell-based incident response framework written by Dave Hull called Kansa. First, let's cover the basics. So, what does Konza do? Borrowing from the project's official GitHub README, which is displayed on screen now, it uses PowerShell Remoting to run user-contributed modules across hosts in an enterprise to collect data for use during incident response, breach hunts, or for building an environmental baseline. This framework can be run across a single host or even tens of thousands of hosts across an enterprise. So yeah, it scales, largely. Before we jump into the next section and take a look at the tool in action, there is one important caveat you should keep in mind. All of the modules utilized by Konza depend upon the Windows API. So that means that an advanced adversary could potentially hide from this framework. Think rootkits, for example. With that in mind, let's hop over to a Windows 10 VM and take a look at how to use the tool. We'll first look at all of the included modules that come with Konza, and then we'll manually run some of those modules to get an idea as to how and what data is collected. Then we'll run the Konza front end and let the tool perform the collection for us. Lastly, we'll wrap up the episode by taking a look at the output. So let's get started. Okay, the first thing we need to do is visit the GitHub page for the Konza project. Here we can either download the entire project as a zip file or grab the URL so that we can clone the project. We're going to be doing the latter. And in fact, I'm going to be using the Windows subsystem for Linux, specifically Ubuntu for Windows, because it already has Git included, and it makes it very, very easy to just go in and clone the entire repo. So we'll click the green button and then we'll click this icon to copy this URL to the clipboard. At this point, we're going to switch over to the new Windows terminal, which, by the way, if you're not familiar with this software, click the card in the top right to watch a 13 Cubed Shorts episode in which I cover the new Windows terminal. So let's go ahead and change into the current user's desktop directory. So to do that, we'll simply go into /mount/c/users/davisrg/desktop. Now all we have to do is git clone and then paste in that URL. And within just a few seconds, we'll have the entire project cloned into the Konza directory on our desktop. Now from this point forward, we'll be living in the PowerShell environment. So with the new Windows terminal, all we have to do is click the plus in the top right to launch the default shell, which happens to be PowerShell. And there we go. Now we are good to go. So let's go ahead and change into the desktop directory. And here you will find the Konza directory, which was just created when we did the git clone. And if we take a look at what's inside, you'll notice quite a few files and directories. The modules directory that you see on screen is where most of the real content of Konza lives. That's where we'll find the PowerShell scripts that do that collection. But before we actually start looking at those individual PowerShell scripts, let's take a look at the modules.conf file, which will actually dictate which of those modules is run when we run Konza. So we'll fire up Notepad and look at modules.conf. Let's go ahead and maximize this. And you'll notice that anything with a hash mark in front of it is commented out or not going to be run when we run the Konza PowerShell script itself. So pretty self-explanatory. If you want to enable any of those, simply remove the hash mark and it will be enabled, or if you want to disable any, simply include the hash mark. So no big deal there, very straightforward. So let's go ahead and close this, and there's one other file I'll go ahead and show you, which is that default-template.ps1. Now this is a little beyond the scope of this episode, but this is a template for creating your own Konza modules, or collectors as they are known. And you can see that there's quite a bit of instruction in here that will actually show you how to build one yourself. Again, not really within the scope of this episode, but if there's interest, I may create a follow-up episode. All right, with that out of the way, let's start taking a look at these various directories. You'll notice ASCP, config, disk, IOC, so on and so forth. Let's go into ASCP, which is our auto start extensibility points, and you'll notice quite a few PowerShell scripts located here. So let's go ahead and look at, for example, get SVC all, which, as the name implies, will get all of the services present on a system. Obviously, this is something that would be very important when we're performing forensics on a system. We want to know which services are installed, and this provides that information for us. You'll notice it's in a nice human-readable format, but of course, when we actually run the Konza script itself, it's going to generate CSV output for us and not exactly what you see on screen in this format, but rather the same data in CSV format. But as you can see, everything is very readable here and all the services are being enumerated. So pretty straightforward. And you'll notice all of these names are named in a way that you can pretty much figure out what it does by looking at the file name. How about get scheduled tasks? Well, as you might imagine, that gets all of the scheduled tasks present on a system. Here you see the Adobe Acrobat Update task, and as we scroll down through here, you'll notice numerous other scheduled tasks present on this system. Obviously, this could be used as a persistence mechanism, as could the services we just looked at. So again, it's very common to look at these kinds of things when we're forensicating a system, and this just provides a collection script to get that data for us. Again, pretty self-explanatory, but it's also in a nice, easy-to-read format. Keep in mind, as I mentioned with the other, it will be in CSV format when we run the Konza script itself. Right now, we're simply running the individual modules, which is perfectly acceptable and perfectly a common use case, just so we can get an idea of the kind of data that is being collected. So if we look at the remaining things in this directory, let's take a look at one more. How about our WMI FLT con bind? So a WMI event filter is the trigger, for example, do something every 30 seconds or something like that. The event consumer is the script or executable that will be run. And then the binding that we're looking at is the combination of both of those together. Again, for persistence mechanisms, this kind of thing could be present. Of course, what we just saw there was a normal built-in Windows function and nothing else. So what about these that say get auto runs? Well, let me go ahead and run this and show you what happens, because these actually rely on a separate sysinternals utility. And if we try to run it, you'll notice it says auto run C not found in C:/Windows. So we got an error message. And this is expected because it does rely on a third-party binary that we would need to copy there before that actually works. Let's go ahead and take a look at the config directory next. Just as with the ASCP directory, the config directory also contains several different PowerShell scripts that are named in a way that makes it fairly easy to understand what type of data they may collect. We'll take a look at two of them, including get-localadmins and get-smb-share. Get-localadmins simply shows us the local administrative accounts on this box, of which there are two, and get-smb-share shows us that, in this case, only the three default admin $, $C$, and IPC$ shares are present on this system. And as you saw previously, there are numerous other scripts available in the config directory. We won't run the rest of them, but you can get a good idea as to the type of data that they collect. Next up is our disk directory. So let's go ahead and change into that. And here we will find PowerShell scripts associated with the collection of disk-based artifacts. We're going to take a look at get-tempdir listing, which, as you might imagine, will show us the contents of various temporary directories that may be present on a given system. Malware could, of course, stage itself here, and there may be other files of interest here as well. You will notice we see the full path and file name of the files located here, along with some file system timestamps. Fairly self-explanatory. And if we look at the remaining files that were left here in the disk directory, of course we have several other options that we could choose from. Very self-explanatory. So let's go ahead and go into our next directory, which in this case is going to be the IOC directory. There's a single script here called get-loki, which does require a third-party Loki IOC scanner. So we're going to go ahead and skip that and go into our next directory, which is called log. And inside of the log directory, you'll notice several different PowerShell scripts, but we're going to be taking a look at get-log user assist. User assist lives in the intuser.dat files, so in the registry associated with each individual user, and it will show us evidence of GUI-based program execution per user. Among the data displayed will be, of course, the name of the binary itself that was executed, the total number of times it was executed, and the last time it was executed. Again, this is a per user artifact because it is stored within each user's ntuser.dat hive, and it's one of the core program execution artifacts that we talk about in the premiere episode of Introduction to Windows Forensics. Click the card above in the top right if you'd like to learn more about this, Prefetch, and other evidence of program execution artifacts that we commonly use in forensics. But as I continue to scroll down through this data, you'll notice there's quite a bit of information here. We can see things like excel.exe and the number of times it was executed, AM cache parser, network miner, and various other pieces of information that will be quite useful. So next up, let's take a look at the contents of the memory directory. As with the IOC directory, we're going to skip over the single PowerShell script located here called get-memory because it doesn't work with Windows 10 and actually requires an older third-party piece of software called Memorize, which was developed by Mandiant. Next up is the net directory, and here we're going to be taking a look at get-arp and get-dns cache. So first up, get-arp is the equivalent of running arp-a on the system. You'll notice the layer 3, layer 2 mappings for our IP addresses and MAC addresses, just as you would expect to see, in a very easy to read format. So this is indeed our ARP table. So next up, let's take a look at that DNS cache script. If we run this, you'll notice that we have no output. So let's go ahead and ping something like 13cube.com, and that should cache the DNS entry. And if we run it again, sure enough, we notice 2 DNS entries for 13cubed.com. We have the A record itself, and of course, one of the name servers that's authoritative for that domain. So very self-explanatory there. And there are several other scripts in the net directory that are fairly self-explanatory as well. We won't actually run them here. And instead, we'll go ahead and change back up a level and go into our next directory. And this also happens to be our final directory, which is called process. So let's change into it and take a look at the scripts available here. And we're specifically going to look at get-prefetch listing, which, as the name implies, will show us the contents of the Windows Prefetch directory on a given computer system. Prefetch, if you're not familiar, is another evidence of execution artifact, only unlike user assist, it is not stored in the registry, is not user-specific, and will show us evidence of non-GUI-based program execution in addition to GUI-based. Just based upon the presence of a .pf file and the creation and modification time, we can determine if something executed, the first time it executed, and the last time it executed. This is an extremely powerful artifact, and of course these individual .pf files can be parsed as well, but we're simply looking at file system data here, just the full path and file name of the PF file and some timestamps. And of course there are quite a few other files located here. We're not going to take a look at the rest, but you get the idea. At this point, we are ready to move on to actually looking at Konza itself, the actual head-end script that we're running, instead of running the individual modules. And that script is called Konza.ps1, as you see here, and it's located in the root of that cloned repo, which is, in this case, the Konza directory. Before we get started, though, let me show you this. In order to enable PowerShell remoting, you need to make sure that your network interfaces are set to private for the firewall configuration. And then you enable -ps remoting. But in this case, I am not using this in a domain environment. This is a standalone workgroup virtual machine. So for this particular example, I have enabled basic authentication instead of Kerberos, which is the default, but we can't use that because we're not in a domain environment. And I've also allowed unencrypted communication, again, for the purposes of this lab. Do not do this in production. This is a very, very bad idea. But again, for the purposes of learning this and running this on a single machine in our lab, I have done this. Normally, of course, we would run Konza in a one-to-many kind of scenario, where we can run it from a particular system to a target system and not running it on the system itself like we're doing here. But we're just learning and understanding how the different pieces fit together and how this actually works. So again, what you see in blue is not a good idea and is just there for this particular lab environment. And yes, I will include this in this episode's description, so you don't have to type all that in. All right, so with that out of the way, To run this, we're going to run Konza.ps1. We're going to specify the target, which in this case is localhost, this VM. We're going to specify the module path, which is where we just were, which is /modules. We're going to turn on verbose mode. We're going to specify the authentication as basic instead of Kerberos, so non-default. And then we're going to specify the get credential for credentials, so it'll actually pop up and ask us to enter the credentials for this to work. So again, this is the entire command line to run Konza, and this will run all of the enabled scripts that we saw in that modules.conf file in the beginning of the episode. So anything that wasn't commented out with that hash mark is going to be run and collected as part of running this Konza.ps1 script. It will do all the work for us and create all the output. And so if we run it, let's go ahead and enter our credentials here, and then we'll let this do its thing. All right, and there we go. Now you will notice that there is one job that failed, a particular WMI collection that failed, which isn't uncommon that some of these would fail just depending on what exactly it is that you're running. In this case, it is expected and okay. But you can see as these various jobs kick off and run, you'll notice the state and various other metadata associated with this information. So we'll give this just a second to finish running, and then we'll take a look at our output. All right, so at this point, it's already finished, and now we can go ahead and look at the output that Konza has created for us, which it has placed in an output_timestamp directory. So you can see the timestamp here that was dynamically created. And if we look inside, you'll notice various subdirectories therein associated with the various PowerShell collection scripts that ran. If we take a look at one of them, I don't know, how about local admins? Well, there you go. There's localhost, which is the name of the machine. Well, at least the name that we specified on the command line. And if we go ahead and cat that, which by the way, cat does work in PowerShell, it's just an alias. And there we go. So we can see the output. And remember, I told you it would be in CSV format. So very easy to understand how that works, and they're all nicely organized for us. But that brings up an interesting point. If these are in CSV format, of course, we would want to use a tool like Excel, or even better, we could use Eric Zimmerman's Timeline Explorer to actually parse this data. So that's exactly what we're going to do. We're going to use Timeline Explorer, and I will open up a few of these and show you just how powerful this tool is. We've used it in several other 13 Cubed episodes, so you may already be familiar with it. But using this, we'll actually be able to very, very quickly parse all of the data. And here it is. Here is Timeline Explorer, and here are 3 files that I've opened. As you can see, netstat, prefetch listing, and scheduled tasks. So these are based upon the collection of those PowerShell scripts, some of which we looked at in the previous section. So as you can see here, this is just straight up output for netstat, and it's nice and easy to read. It's created the columns for us, and as we scroll around, again, very easy to interpret what's going on here. But what's really cool is that we can drag a column header up to this area, and now check that out. We have actually grouped them by IP address. So now we can simply go through and click on these little disclosure arrows here and actually start looking through all of this data. So it's very, very clean and organized and easy to parse using Timeline Explorer. And of course, up here I can type in something like Chrome, and it will automatically filter on chrome.exe in this case and show us any netstat output associated with that. So next up, let's look at prefetch listing. So as you can see, this is what we saw in the previous section when we looked at the individual prefetch files. So if I go over here and simply type in something like cmd.exe, boom, there you go. There's the prefetch file for cmd.exe, and there are our timestamps. So we can derive the first and last time of execution and various other pieces of information. So extremely easy to use, and all I did was simply type cmd.exe. And then last up, we have scheduled-tasks.csv, and as we scroll down through here, we can see all of those numerous scheduled tasks that were present on the system. If I type in something like Adobe, there you go. Those are the Adobe Acrobat update tasks that we saw when we looked at the output in the previous section. And you can see things like the next runtime, the logon mode, the last runtime, and various other pieces of information that I won't bother to read out to you because you're fully capable of seeing it on screen here, but you get the idea. So, using Timeline Explorer, it's very easy to parse this Konza output. So that wraps up everything I wanted to show you, at least everything I wanted to show you in this introduction to Konza episode. There will be hopefully follow-up episodes if there's interest. Just let me know in the comments below. But this is enough to at least get you started, and I hope that you can see how powerful this tool is. So in a lab environment, I encourage you to play around with this, and if you're using PowerShell Remoting in your corporate environment, which I hope that you are because that is the preferred and new way to manage things. Hopefully you're not still using PSExec and whatnot to execute things across your systems. But if you have PowerShell Remoting enabled, then I would encourage you to take a look at Konza. It is a very, very powerful incident response framework that can help you go through and enumerate one-to-many and gather data on numerous systems at once. As I mentioned before, the caveat is this does rely on the Windows API, so if you have advanced malware or something that is trying to hide from you, it's not going to show up here. So remember, this is using standard Windows API calls to bring back the data to you, but still quite a bit of useful information can be gained from using this Konza framework, and it's very extensible and expandable. You saw that you could write your own modules and really extend it in any way that you see fit, and we've only scratched the surface here. So I hope this has been informative and useful, and as always, I'd like to thank you for taking the time out of your day to watch this 13 Cubed episode. I look forward to the next one, and I will see you then. Take care.